Hello, boys and girls, and welcome to another episode of your favorite algorithm channel. My name is Ryan Powers, and today I'm going to be taking you through Elite Code 39 combination sum. So let's introduce the problem. Given a set of candidate numbers, candidates, without duplicates, and a target number, target, find all unique combinations in candidates where the candidate numbers sum to target. The same repeated number may be chosen from candidates unlimited number of times. Okay, well, that part is important. Let's take a look at these notes here. So all numbers, including target, will be positive integers. Well, that's helpful. And the solution set must not contain duplicate combinations. So we can use the same number more than one time, but we cannot repeat the same grouping of numbers, no matter what the order is. So let's take a look at the example and talk about that. So we have 2, 3, 6, and 7, and our target is 7. So we can use 2 as many times as we want, or 3, 6, or 7 as many times as we want to sum up to 7. So we have this number here, 7. So our solution set is 7, and then 2 2s and a 3. So we couldn't say like 3, 2, and 2, right? We can only say 2, 2, and 3 one time. That grouping of numbers can only exist one time. And then we have 7 here. So here's another one. So we have the numbers 2, 3, and 5, and our target sum is 8. So our solution set is all 2s, a 2 and 2 3s, and a 3 and a 5. So hopefully this kind of makes sense to you. Anyways, as always, I suggest that you try to solve the problem on your own first. And if you can't figure it out, or you just want to see how I did it, then check out the video. Otherwise, if you're ready to get started, come with me to the whiteboard. On the screen here, I have our array, which is 2, 3, and 5, and we are going to be searching for the target sum of 8. So we're looking for all the possible sets of numbers that we can create with 2, 3, and 5 that add up to 8. And what's the strategy we're going to use to solve this problem? Well, we're going to use a depth-first recursive approach to solve this problem. And how we're going to do that is we're going to iterate over this array of numbers at every recursive call, and we're going to keep using the first number until we can't use it anymore. So what do I mean by using this number? Well, we're going to keep using 2, and to do that, what we're going to do is we're going to subtract 2 from our current target, and as long as our current target remains above 0, we can keep using 2. Once our target sum reaches 0 or below, well, we know that we've either found a solution set or we have overshot our target. So let's draw out this recursive structure to get a better idea of how this function is going to execute. And once we draw the recursive tree, we should have a pretty good idea of what our function should look like. So the first thing we're going to do is iterate over the set of numbers, and we're going to take 2. That's the first index in our array. So that's what this pink number is here. It's representing at what iteration am I in the array in that current execution context. So the solution set that we have now is 1, 2, and we can remove 2 from 8, which is going to give us a target sum of 6. So we'll keep track of our target sum using this blue number here. And because our target sum is still greater than 0, we can keep using 2s. So we will explore all the possibilities using 1, 2 with a combination of more 2s, right? So we'll keep track of the fact that we're using 8 up here on the top, and we'll add another branch to this call to our function with 1, 2, and we'll add another 2 to our solution set. Well, our target's now going to be 4, and it's greater than 0, which means we can add a 2 to all the possibilities that include 2 2s, right? So we'll add a 2 to that, and we'll subtract 2 from our target sum, which is going to be 2, and we can still add one more 2. So we'll add a 2 to all the possibilities of sums that can be created using 3 2s. We'll add a 2 to that, which is going to give us 4 2s and a target sum of 0. So now we've reached our first solution set. And we know we've reached a solution because our target sum is 0, meaning that we have subtracted numbers that have accumulated up to 8, meaning that we have reached our target sum. So we can actually record this solution set in our combos array. So now we have our first answer, which is 4 2s. Well, we can't add anything more to this, right? Because if we did, our target sum would be negative, meaning that we have created a number that is greater than 8. So we don't want to do that. So we're going to return from this call, back up to the execution context where we are exploring all the possibilities of combinations of numbers that include 3 2s. And we'll try to use a 3 with this combination of 3 2s. So we'll iterate to the next item in the array of numbers, and we'll try to use a 3 with 2 3s. Well, that's going to give us a combination or a target sum of -1. So we've overshot our target, meaning we need to return from this function call back up to this context where we're using 3 2s, and we'll explore, can we use a 5? So we'll try to use a 5. Well, that's going to give us a target sum of -3, so we'll return from this call back up to the execution context where we're trying to explore all possibilities using 3 2s, and we have iterated through all the possible numbers that we can add to 3 2s. So we'll return from this function call where we are using 3 2s, and we'll return back to the execution context where we were exploring all possibilities using 2 2s. So now we'll try to use 2 2s with a 3. So we'll iterate over to the next item, which is going to be our 3, and we'll try to add a 3. Well, that's going to give us a target sum of 1. So we can keep adding 3s to this. So we'll add another 3. That's going to give us 2 2s and 2 3s. Well, that's going to give us a target sum of -2. So we'll return from this function call, and we'll try to add a 5. So that's going to give us 2 2s, a 3, and a 5, which is going to give us a target sum of -4. So we'll return from this call back to the execution context where we've used 2 2s and a 3. Well, we've explored all the possibilities with this combination. So we can return back up to the execution context where we're exploring all possibilities using 2 2s, and we'll try to add a 5. So that's going to give us 2 5s, or 2 2s and a 5, which is going to give us a target sum of -1. Well, we've overshot the target again, so we'll return to the execution context where we're using 2 2s, back up to where we're using 1 2, and now we'll try to explore, can we add a 3 to 1 2? Well, that's going to give us a target sum of 3, so we can add another 3, and that's going to give us a 2 with 2 3s, which gives us a target sum of 0. So we found another possibility. So we can add that to our combinations, and we'll return from this function call, and we'll try to add a 5 with a 2 and a 3. Well, that's going to give us a -2, so we'll return from this call, and we'll return from this call again because we've explored all the possibilities, and we'll go back up to where we have 1 2, and we'll try to add a 5. We'll try to create a combination of 1 2 and a 5. Well, we still have 1 left over, so we can try to add another 5. Well, that's going to give us 12, which is going to give us a target sum of -4. So we can return from this call. We have no more numbers to add to our 2 and 5. So we'll return back up to 2. And as you can see, we've explored all the possibilities with 1 2. So we'll return all the way back up to the top of our tree. And we'll explore all possibilities using just a 3, just 3 and 5s, right? So this first branch that we created was all the possibilities we could create using all of our numbers. So now we'll try to create our possibilities using just 3 and 5. So the first branch that we have here is just 3. Well, that's going to give us a target sum of 5. So we can keep adding 3s, so we'll do that. So now we have 2 3s, and we're now iterating over the item at the first index in the array. And that gives us a target sum of 2. So we can add another 3 to that, which gives us a target sum of -1. Well, we've overshot the target, so we'll return from here back up to where we have 2 3s, and we'll try to add a 5. Well, that's going to give us a target sum of -3. So we'll return from this call. We've explored all the possibilities with 2 3s. So we'll return back up to where we're just exploring the possibilities with 1 3, and we'll try to add a 5 to that. Well, that's going to give us 3 and 5, which is a target sum of 0. So we can add that to our combinations. So we'll do that. And we'll return from this call because we can't add another 5 to this. And we've explored all the possibilities with 1 3, adding 3s and 5s to 1 3. So we'll return from this call back up to the top of our tree, and we'll explore all the possibilities using just a 5. So the first set is just 1 5. So that gives us a target sum of 3. We'll try to add another 5 to that. Well, that gives us a target sum of -2. So we've overshot the target. So we'll return from this call, and we've explored all the possibilities using just 5. So we'll return from this call as well. And we'll return all the way back up to the top of our tree, where we've explored all of our possibilities, and we'll return our combinations. So our current combinations that we've come up with are 4 2s, a 2 and 2 3s, and a 3 and a 5. So now that we have a better idea of how this recursion tree is created, let's see what it looks like in code. So now that we've seen kind of the recursive strategy of solving this problem, how are we going to implement this in code? Okay, well, we're going to be using this combination sum function. And what we're going to be keeping track of here is our current list of candidates. So this is the list or the array of numbers that we have to use. We're going to be keeping track of our target. So this is the target sum that we're shooting for. We're going to keep track of our current index. So this is the current index. Which is basically, okay, what number in candidates am I currently utilizing? And then we're going to be keeping track of something called current, which is just going to be the current array of numbers that I am using to try to sum up to target. And then, of course, we need to keep track of all of our different combinations. And this is what we're going to be returning at the end of this function. So I think the first thing we should take care of is our base case. So what is our base case? Well, our base case is long as our target sum is greater than 0, we want to keep subtracting from target, right? Because that means we have not reached our target yet. So when do we want to return from this function? Well, we want to return from this function when target is less than or equal to 0. So if target is less than or equal to 0, then we want to return. But this isn't the only thing we want to do here, right? Because if our target is equal to 0, then that means that we have a valid set of numbers that sum up to our target. So if target is equal to 0, then we want to push that set of numbers into our combinations. So we'll do combinations dot push a copy, so current dot slice of our current set of numbers. Okay, so this takes care of the base case of this function. But so now we need to code out this idea of like taking this first value over and over again until we've either hit our target or overshot our target, and then removing a number and then trying the next one, right? So how do we code this pattern? Well, let's take it one step at a time. So the first thing we need to do is grab whatever value we're working on. So we'll just create a constant and we'll just call it value. So what's value going to be? Well, value is going to be candidates at the current index. Okay, so this is going to give us the current value that we're working on. And then what do we need to do with this value? Well, we want to add it to our array of items that we're going to use, right? So that would be our current list of items, or our current array of items. So we'll do current.push value. Okay, so now we've added it to our list of items, and now we need to make a recursive call to our function, our combination sum function. So we'll do combination sum, and we need to pass along candidates, and we need to pass along our target. But do we want to pass on our target? No, we need to subtract the current value that we just used. So in our previous example where we're using 2, 3, 5, so we're using 2 over and over again. Well, we need to subtract 2 from target because we're starting at 8. Now we're going to use a 2. So now our target needs to go to 6. So we need to do target minus value. So we're subtracting our target. And then we want to, we don't want to change our index, right? Because as long as our target is greater than 0, we want to just keep using the same number. Okay. So we'll pass along the current array of items, and then of course we'll pass in our combinations. So now we've set up this idea of continually using the same number over and over again, right? So in our previous example where we had 2, 3, 5, and our target sum was 8, well, if we look at this function, we can tell what it's going to do in the first kind of the first branch of this recursive structure, right? So we're going to go through this function and we're going to add a 2. So we'll have 1, 2, and then we're going to make a recursive call, right? And then we're going to add a second 2, and then we'll make another recursive call, adding a third 2, and then we'll make another recursive call, adding a fourth 2, and then when that goes through, our target sum is going to be 0. So we're going to enter our base case. We're going to push that into our combinations, and then we're going to return from that function call. So what's going to happen when we return, right? Well, when we return, we're going to return to the previous execution context, which is going to be this line right here, line 14, where we just called combination sum with 4 2's. So we're going to return from that function call to this line in the code. So now we're going. So what do we want to do when we return from that function call? Well, we want to remove a 2, right? Because we just used the 2. We used the last 2 we could possibly use, and now we need to try adding a 3, right? So how do we remove a 2? Well, we just need to do current.pop, right? We just want to remove the last item we had just added, and then we want to make another call to our function using a 3 this time, right? So how do we do that? Well, we'll make a recursive call to combination sum. So combination sum, and we want to pass along our candidates. Okay, so candidates, and then we want to pass along our target. Okay, but we don't want to subtract the value, right, this time, because we had just this value here in this execution context is a 2, right? So we want to make a recursive call using a 3, and we want to subtract 3 this time. So we won't subtract from our target, and we want to instead increment our index, right? So now we want index plus 1, so we want to go from index 0 to index 1 using a 3 this time instead of a 2, and we'll pass along our current set of numbers, and of course, we'll pass along our combinations. Okay, so this is pretty much the structure of the function. We have just coded out the pattern that we need. This pattern of using the same number until we can't use it anymore, then taking that number out, putting the next number in, and just doing this, and we'll return. So this is the exact pattern that we needed to create. So there's one thing that we're missing here, and that is when our index is greater than the length of our array, well, we don't want to make any more recursive calls because we've used all the numbers that we can use. So we can just add an if statement here. So we can just say if index is greater than candidates, or we'll say if index is less than candidates dot length, then we want to make these recursive calls. Otherwise, we want to just return our combinations, right? So I think I took a curly bracket there. All right. So we'll move this inside of our if block. So now we will only be making calls, recursive calls to our function when we have numbers left to use. And then at the very end, we just want to return our combinations. All right. So this is the entire pattern for solving this problem. Let's just do a quick little recap of what we've done. So our base case is if our target sum is less than or equal to 0, then we want to return. If our target sum is equal to 0, well, that means that we found a set of numbers that sums up to our target, and we want to record that in our combinations array. And now, if our index is less than the length of our list of candidates, well, then we want to make recursive calls to our function. The first thing we're going to do is we're going to push in the current value that we're on, making a recursive call. And then when we return from this call, when we have either reached or exceeded the target, then we want to take out the last value that we had just used, and we want to increment the index and use the next value in our array of candidates. And then we want to return our combinations at the very end. Okay, so let's see how we did. All right, so let's submit here, see if we have any bugs. Okay, 63%. So I think we're in range of the best solutions. We can take a quick look at the distribution here. All right, let's zoom in on this, and let's grab this best solution just for my own morbid curiosity. And we'll paste this in here. All right. Okay, so we're in range of the best solutions on LeetCode. Anyway, what I wanted to talk a little bit about was the time complexity of this problem. If you've noticed, I haven't covered it yet in this video, and to be completely honest, the time complexity of this solution is a little bit outside of my range of ability to explain. I spent a lot of time trying to understand just exactly how to quantify it, but I wasn't able to get a really good handle on what exactly the time complexity of this problem is. So I will challenge all of you math wizards out there. If there are any of you out there who are watching this video and you do have a good handle on the time complexity of this problem, please leave a comment in this video so you can help educate myself and also other people who are going to watch this video. Anyway, I hope that you learned something. And in spite of me not covering the time complexity, I hope you enjoyed the video, and I hope to see you in the next one.